Welcome to Cast Designer. This course is designed for the CPI setup in Cast Designer. It is also another major step for a CPI model. We will set the casting material and properties, process control parameters and other running parameters. It is also called preprocessors in some CAE system. The setup capability of Cast Designer CPI is fully integrated to the same user's environment with the CAD and Mesh modulus. At first, we start the Cast Designer software. Then we load in the Cast Designer model to user's environment. The model should include the 3D mesh, which generated by FastMesh or other meshing tools, also the 3D CAD model. In fact, the 3D CAD model is usually not used in the CPI setup process. So you even need not input the CAD to the user environment for a very big model to speed up the system. Also, in here, we can hide the geometry model and only display the mesh model. Cast Designer CPI uses the objective concept for model setup. In this case, any physical attribution should apply to the objects. This provides a very flexible method for part exchange. In this case, we need prepare some objects before the CPI setup. The first object we need created is the nodes of piston. Because we will apply the temperature and velocity to such nodes. The operation is very simple. We activate the node selection mode, adjust the view, and select all the nodes of the pistons. Then press the right button of the mouse, and add the selected nodes to a new object. Such as Inlet BC, press Add to set the data to the new objects. After that, we have success generated a new object named Inlet BC. It has displayed in the object list table. We also need generate an object for heat transfer. It meaning is, the heat will transfer from the skin elements of the casting, during and after the filling process. We use the skin of solid function in the function panel. And set the object name to skin in the common node optional, then extract it. A new object named skin is also generated and listed on the object list table. Now, there are 3 objects in the mesh list table. The casting part, which is 3D elements type. And Inlet BC for piston, skin for heat transfer. Then, we go to the CPI setup. Let's press the CPI setup function, from function panel of Cast Designer. There is also only one page of the CPI setup. From up to down, there are 5 function regions in the interface. The process template, the object lists to define the object material, and properties related to the objects, this is the second functions. Then a list table of heat interface in the left, and the boundary condition table in the right region. The last one is the process parameters, and run parameters, which is located in the bottom of the window. Now, we start from the template. Almost casting process and simulation type are summarized in the template, such as high-pressure die casting process, gravity casting process, and low-pressure die casting process. Each process also includes some sub-process, or simulation type. Almost parameters of the process and simulation type are defined by the system. We select the high-pressure die casting process, and filling and solidification as simulation type. Press Apply, then confirm the Windows information, and come back the main interface of CPI setup. Let's look the optional button. It is mainly used to define the heat transfer coefficients between heat interface. We can change it before any setting. Such changes will take effect for the following all settings. For example, we can adjust the heat transfer coefficients between casting to mold, or casting to core, and others. Of course, if the user doesn't make any change in here, they still can make adjust in the later one by one. We begin add objects to the setup. After press the plus button, a submenu for object setup will appear. We select the part in 3D mesh from the object list table in the left of the windows and set the part type to casting. The filling status is empty, since we will make calculation of filling and solidification. Now, we press the load button to load a casting material from the material database. Cast Designer has more than 400 materials in the database. Also, it is easily to generate users' material data and save to database. We select the aluminum type and ALSI 9CU3 material for casting. We also can use the read button in the right of the windows to check the detailed material properties for that. After that, we select the material and come back. After set the material to casting, the liquids and solids temperature will be displayed under the material name. This is useful to have the reference for checking the other input parameters. We also need set the initial temperature for casting. It is the pouring temperature or ejection temperature. Normally we can set 50 degree above to the liquids. In here, we set to 650 degree. Press apply button, then the part has added to the objects list. Then, we set a quick mold. It is a fast way, if you only have the part but no detailed mold geometry. For quick mold, no detailed geometry is required. The user only input the boundary box size, material data, and initial temperature. For the mold size, normally we can set a big number, like 5 times of boundary box of the casting part. For initial temperature, you can press the tips button to get some help from system, which is based on the industrial experience. Here, we set 230 degree for aluminum. And the material of quick mold, we can set to steel H13. Also, press apply button to add the quick mold to the object list. Once the objects has been assigned, the heat interfaces will also be generated automatically, except the parts with disconnection mesh. For this model, the heat transfer coefficient was set to 1000 automatically. We can change to 2000, since the mold is steel. There are also some wizards to help the HTC setup, such as water cooling channel, or air cooling channel. We go to boundary condition setup. At first, we need set a temperature, also a velocity to the nodes of piston. For temperature, we set 5 degree less than the pouring temperature, or ejection temperature which defined above. For example, 645 degree in this example. For piston velocity, at first, we define the direction. It is negative y direction in this example. And we can set 2 meter per second as value. If you are not sure, you also can get the help from the velocity wizard. With this wizard, the user can input the filling time and section area of the piston, then the system will calculate the velocity automatically. Moreover, even if the filling time also can be suggested by another filling time wizard. So, there are lots of online help and wizard in Cast Designer. In this case, we still keep -2 meter per second as the velocity in y direction. We also can set a 0 velocity for the whole casting part. This is a standard setting for casting and filling simulation. The last boundary condition is, assign a heat transfer condition to the skin of casting. This condition is unnecessary sometimes, since we have set a quick mold already. However, the quick mold doesn't transfer heat out of the whole system, so it will cause a longer time for solidification or cooling process. In this case, this boundary condition may be useful. We simply select the object, and the air mode for the heat transfer defined. Now, we have defined 1 temperature boundary condition, 2 velocity boundary condition, and 1 heat transfer boundary condition. That is all. And, we set up the gravity direction, following the interface from up to down. Then we come to the control parameters. For control parameters, usually you need not spend too much time on that, since it was defined well in the template. Cast Designer has fine-tuning to different process, in different parameters. In this example, we only changed the process time to 80 seconds, and the final temperature to 400 degree. The other parameters will use the default value. So, we finished all the definition of the casting process. Now, we press the Create button to generate the input deck for solver. Cast Designer Solver uses special file format. Only this function can generate the solver input format. Also, the system will check the input at first, then go to the solver input generation. Depend on the model size, this may need a few seconds, or longer. Please wait. Now, the solver input deck has been generated. Let's check what have done by the system. We go to the project directory, then solver directory just generated. We can find there are two files. The first one is named CETAT, which is the solver input deck. And another one is named CSF, which is the setup parameters of the whole CPI setup process. It can be used for model checking, or assigned to a similar project, to save a lots of time. For example, if you have another similar model, and use the same CPI parameters, you just open the CPI setup interface, and load the pre-saved CSF file, assign the object again, then the setup is finished. This is very useful if we change some geometry or meshing. Also, it is possible to be used for some optimization programs. Now, we start the job submit interface to start the solver. If you are a single process version, you only can use one CPU, or process, or core. If you have purchased a parallel version, you can select numbers of CPU. The solver will check the data at first, then start the simulation. So, this is the main topic of this course. Please make some exercises after the course, and play the CPI setup parameters by yourself. With more understanding of Cast Designer, you will like it more. Goodbye!